On October 7, 2025, the European Space Agency unveiled its initial official shots of Comet 3I/Atlas as it zipped by Mars. Everyone anticipated stunning clarity that would ignite wonder worldwide. Instead, fury exploded, a vague smudge, zero word from NASA, China, or the UAE, and not a trace of the crisp info folks had been craving. How could this blockbuster Mars encounter, the one that shattered online records, leave us with nothing but puzzles? And what secrets might these organizations be shielding with their gadget-based alibis? When amateur stargazers snap crisper views than those mega-budget probes, and whispers of bizarre compositions begin to circulate, it's clear one truth stands out. The true narrative is only starting to unfold. So, what's getting withheld from us? Precisely at 9:22 Universal Time Coordinated that day, the debut ESA visuals of 3I/Atlas hit their official outlets. In moments, top science influencers, avid space fans, and even joke-filled social pages shared that lackluster snapshot far and wide. It showed a dim, hazy speck scarcely standing out from the surrounding pixel clutter. Come midday, ESA fails was blowing up in four tongues. Tags such as #BlurryBlob and #Where'sTheGoodStuff exploded on X and Reddit, where desk-bound experts picked apart each tiny element. The backlash went beyond mere letdown. Folks poured in contrasts, pitting home setup scopes against the pricey European Mars satellite, revealing superior sharpness from the amateurs. Posts slammed the agency for concealing details, especially amid the eerie hush from NASA, China, and the UAE. Each unresolved query ramped up the demand for genuine answers. The KSSGS instrument on the ExoMars Trace Gas Orbiter wasn't designed to pursue cosmic wanderers from afar. Its primary role involved scanning Mars's terrain in vivid hues, spotting avalanches, and monitoring shifts in sand and ice layers. Aimed at 3I/Atlas from 30 million kilometers off, its specs turned into a major drawback. Every pixel in the CASI-S sensor spans roughly 340 kilometers at such a range, plenty to engulf whole Martian peaks, much less a comet core possibly just tens of kilometers across. With a resolution of 11.36 microradians per pixel, it imposes a strict boundary. Regardless of flawless sharpening or extended capture times, features tinier than 1 pixel just smear out as indistinct glow on the detector. Nick Thomas, the lead researcher, described it as a real push just to spot anything. The comet shone at least 10,000 times dimmer than the planetary details the CASI-S system targets. Engineers layered multiple shots, refined the motion following, and extracted every scrap of usable light from the chaos. That resulting indistinct blob wasn't some conspiracy. It hit the hardware's absolute limit. The surrounding coma, a vast haze of vapor and particles spanning thousands of kilometers, merges seamlessly with the void, hiding the central body completely. The laws of optics don't bend. From this far out, Mars's top tech can merely verify the object's existence, not uncover its mysteries. Observers yearned for a vivid snapshot. All the device delivered was a basic trace. The upcoming chance for finer insights hinged on another tool or a shifted vantage point. HiRISE, the super-sharp imager on NASA's Mars Reconnaissance Orbiter, was billed as the ultimate backup. Its lenses resolve paths left by rovers from space. Even at 30 million kilometers, it was set to offer at least a peek, perhaps several pixels, into 3I/Atlas's heart. Yet during the event, HiRISE vanished from action. The U.S. government closure that kicked off on October 1st paralyzed the works. No instructions sent up, no updates logged, no datasets shared publicly. Official lines stayed mute for days. Hobbyists and experts kept checking the HiRISE repository, hoping for campaign updates. Zilch showed up. Advanced schedule docs, usually available early, had disappeared too. As NASA's stream stalled, eyes shifted to Mars's alternate watchers. China's Tianwen-1 craft and the UAE's HOPE probe had monitored the comet's nearing path. Still, no photos, comments, or rebuttals emerged from either. The quiet intensified. Sure, some blamed the shutdown outright, but skeptics wondered why agencies across two continents all clammed up together. Lacking solid info, gossip rushed in to fill the void. Each passing hour sans response spotlighted the gaps, not merely better views, but the nagging feeling that elite observatories were under gag orders. HiRISE's no-show stole the spotlight. Without that prize gem, online crowds scoured for indie proof, and every loose end fueled doubts of deliberate obscurity. Right after the ESA's fuzzy speck blew up online, the battle of snapshots ignited. Stargazers from Italy to Japan uploaded their takes. A few featured elaborate merges of scores of exposures. Others deployed AI enhancers vowing to expose concealed forms. By October 9th, online debates fractured into factions. One side insisted on spotting a defined center, perhaps a suggestion of a streamer or outburst, insisting that consumer gear had eclipsed a billion-euro satellite. Another faction cautioned that each additional feature was merely a mirage, a phantom emerging from excessive manipulation and hopeful imagination. Maya Trin, a prominent comet spotter based in Melbourne, emerged as the leading figure for the initial group. She shared a series of progressively refined photos, each marked with notes highlighting what she described as irregular lines near the core. Her updates garnered tens of thousands of reposts, sparking widespread conjecture about oversights or concealments by experts. However, seasoned stargazers countered swiftly, sharing juxtaposed visuals and conducting models. They demonstrated that layering dim exposures heightened stray interference, transforming particle hits and faulty sensors into bogus patterns. According to them, artificial intelligence enhancements merely sharpen these flaws without improving the accuracy. The discussion quickly delved into specialized territory. Concepts such as sigma clipping, deconvolution, and pareidolia surged in popularity across online discussions as enthusiasts dissected unprocessed files to uncover reality. Several observers noted that even an ideal composite at Cassini's 340 kilometers per pixel resolution couldn't distinguish a comet core that tiny. The clearest images from hobbyists, upon closer inspection, typically depended on heavy alterations that sparked more doubts than resolutions. As fresh, enhanced shots appeared, the boundary between breakthrough and fabrication grew indistinct. Online enthusiasm for specifics surpassed the honest limits of the information available, amplifying calls for methodical, open scrutiny. If anything noteworthy existed, it would require more than digital sleight of hand to validate it. Unidentified messages started spreading prior to the initial ESA captures peaking in popularity. As the network of whispers grew, so did pleas for authentic records. The web's craving for clarity now rested on forthcoming verifiable details, orbital calculations, transmissions, or any element open to verification. In the meantime, the onus of validation remained on the proponents, rather than the doubters. Mallory Lefferland, the lead for Perseverance's operations, encountered an issue beyond the standard protocols. The vehicle's navigation camera wasn't designed for pursuing comets, particularly one hurtling by Mars at close to 90 kilometers per second. Yet on October 7th, she greenlit a unique protocol. 10 minutes of uninterrupted celestial shots, aiming to glimpse a hint of 3I/Atlas as it sped through Jazero's visible range. The unedited images revealed a solitary dim trail. It spanned slightly more than 1 pixel in width, angling across the frame. Initially, it resembled a technical error or a stellar particle strike, yet the schedule aligned precisely with the comet's forecasted transit, down to seconds. The underlying arithmetic for the blur was straightforward, though its consequences were not. Traveling at 90 kilometers per second, 3I/Atlas would traverse roughly 54,000 kilometers over 10 minutes, matching the extent of the Navcam mark. Assuming the full duration of the series, the trail conformed to expectations for movement smearing. A remote body in rapid motion, undetectable in a brief snap, but apparent as a streak when accumulated across the interval. However, a complication arose. For a brief single exposure to yield the same trail length, the origin would need to be far nearer, possibly circling Mars itself. Absent the raw FITS metadata, the duration and rhythm of shots remained confined to the vehicle's records. All estimates hinged on that absent piece. Did this represent the comet or a closer entity streaking overhead? Lefferland's choice transformed a hazy buzz into a verifiable assertion. The Navcam trail provided the initial concrete figure amid endless guesswork, a 54,000 kilometers enigma. Heading into subsequent signal monitoring and path verifications, the figures established the threshold separating proof from interference. A vector originating from Jezero crater on October 7th aimed nearly straight at a celestial position renowned for a single event, the WOW signal. Back in 1977, an antenna at Ohio State detected a 72-second pulse at 1,420 MHz, the hydrogen frequency. Its origin remained elusive, but the location persisted in SETI archives. With 3I/Atlas traversing mere degrees from that zone, the alignment defied dismissal. Discussion boards overflowed with rough computations. To replicate the WOW intensity from a broadcaster 600 astronomical units distant, it would demand at least half a gigawatt, possibly double, if directed squarely at our planet. That's equivalent to a large facility's energy focused across space. Still, despite the buzz, no facility made public hydrogen band observations from the encounter. No organized observation effort, no unfiltered spectral releases, not once a negative finding. The quietude extended beyond visible light now. It encompassed radio waves as well. The inquiry lingered unresolved. Given the spatial setup and figures laid bare, why hadn't anyone attempted the most basic verification? On October 29th, 3I/Atlas dropped behind the Sun as viewed from Earth, fading into a brilliance so overwhelming that top observatories lost sight. For almost 40 hours, no Earthbound facility could follow it. The comet's solar separation, its offset from the Sun, contracted beneath thresholds safe for all except the most protected instruments. During the period of invisibility, speculation proliferated across various hypotheses. Certain stargazers cautioned about potential natural eruptions or even disintegration, the typical destiny for comets facing intense solar radiation. Meanwhile, those examining trajectory simulations openly pondered whether a deliberate adjustment, perhaps artificially induced, could be occurring beyond detection. The Galileo Initiative, focused on detecting evidence of extraterrestrial engineering, initiated nonstop monitoring of all accessible radio frequencies and visual spectra, anticipating irregularities as the entity approached its closest solar point. Deprived of direct observations from the primary occurrence, observers worldwide relied solely on simulations and conjecture. Upon the return of 3I/Atlas, its luminosity, path, and potential debris would serve as crucial indicators of both cosmic caprice and the boundaries of earthly observation capabilities. In early November, a series of evaluations awaited 3I/Atlas. Experts scrutinized light variation graphs for abrupt declines or spikes that might indicate splitting apart. Updated trajectory computations, fed with fresh inputs, probed for subtle deviations suggesting gas ejections, vapor releases, or more peculiar phenomena. Every datum represented a verdict. Would the comet's glow diminish predictably, or would it shatter into pieces? Actual paths were compared to forecasts, scanning for any anomalous alterations. At the same time, the JUICE probe anticipated its viewing opportunity toward month's end. Its sensors offered novel insights, though unprocessed information wouldn't arrive back on Earth until deep into 2026. In the interim, any variation in the comet's route or intensity acted as a hint, while postponements in sharing results sustained global uncertainty about what endured the solar encounter. The October heavens weren't dominated by 3I/Atlas exclusively. Mere days prior to the comet's Mars encounter, a near-Earth body designated 2025 TF grazed our planet, darting within the paths of navigation satellites undetected. This modest rock, spanning just meters, dodged all primary detection efforts until it loomed nearly directly above. It served as a stark alert that, despite comprehensive sky vigilance in our time, compact and swift objects can remain elusive. On another front, a pair of comets charted their erratic paths. C/2025 A6 Lemon started intensifying far sooner than anticipated, suggesting an imminent surge. C/2025 R2 SW garnered notice for its proximity, just 0.26 astronomical units from Earth, fueling expectations of a discernible coma and concerns over abrupt breakup. These incidents emphasized the constraints of modern tracking, where unforeseen developments might emerge from any angle or magnitude. The takeaway: the universe brims with near misses, and our vigilance falls short of perfection. On October 7th and 8th, 2025, the European Space Agency unveiled the initial formal snapshots of 3I/Atlas, a mere fuzzy, igniting worldwide discussions and demands for openness. The scant resolution stemmed from CASIS's instrumental constraints, rather than intentional withholding. Still, the concurrent quiet from HiRISE, Tianwen-1, and HOPE created unresolved voids in the information landscape. Though social media buzzed with citizen-captured photos and ongoing whispers of odd radiations or calculated adjustments, authorities have yet to validate such assertions. The streak in the Perseverance rover's guidance imagery aligned with the anticipated motion smear for a body moving at 90 kilometers per second, yet competing interpretations lingered undismissed. As 3I/Atlas slipped behind the Sun during perihelion, watchers shifted focus to early November for evidence of breakup or path deviations. The postponed JUICE assessments, alongside the fresh skim by Near-Earth Object 2025 TF, illustrate the persistent hurdles in observing rapid, erratic intruders. To this point, the authentic essence of 3I/Atlas stays unresolved, underscoring the constraints alongside the pressing need for transparent information in space research.